So when we talk about projectile motion, we are talking about an object that we're going to throw in the air at an angle with some velocity. Okay, well, in order to get it in the air, it has to have some velocity, right? So we are going to write this parametrically. Okay, what I'm going to have you do is write down these two equations, and then I'll tell you what everything means. But if we are going to throw something in the air, hit a ball, kick a ball, throw a ball. I'm just thinking of sports analogies right now. No, we're projecting it. Not stopping it. Okay? Then the path that it follows would be modeled by this set of parametric equations. So yes, we will see some soccer and football and baseball examples. Oh, golf. Oh, and a cannon. We will do a cannon. Okay, so let's talk about some of these things here. What do you think T stands for?
Time.
Okay. Oh, I didn't plug this in. T is for time, and specifically, it's going to be in seconds, based on some of the other numbers that I have thrown in here. Okay, specifically that -16. That H sub 0. H usually stands for height. Okay, so H sub 0 is the initial height. What about V sub 0? Initial something, right, because of that sub 0. So V is going to be, very good, velocity. And since we have that -16 in there for 1/2 times gravity, we are talking about feet per second. This 16 is 1/2 times 32. 32 feet per second squared is the force of gravity in, if we're talking about the system, not the metric system. Okay. What else do we have in there? Theta. What do you think theta is?
The angle
at which it was thrown.
Okay. The angle from the horizontal. Okay. Okay. Now, we've separated this motion into a set of parametric equations. Okay. X is describing what kind of motion? Horizontal. Y is describing our vertical motion. So if I'm asking you a question about how high the ball is, we would want to work with the Y equation. If I'm asking you something about how far the ball went, you would want to use the X equation. Okay? So first of all, we need to be able to understand how to set up these equations, but we also need to understand how to use them. What number do we plug in where, and which equation do we choose for certain scenarios that I ask you to solve? So what we're going to do is we're going to go through a problem that has multiple parts. Okay? I think we're going to do 5 different things with this one problem. And then I'm going to give you your homework, and we are going to work on number 1 together as a class. Okay? So, write down what you need to. But go ahead and just read through the problem. Without writing anything down, read through the problem. Okay, so what I want you to do is, as a pod, take those two equations and just see if you can assign numbers to the different variables we talked about. T will always be T, but see if you can figure out what is theta, what is B naught, what is H naught.
The B is not.
Like you can talk to each other right now.
Yes.
Yeah, theta. Yeah, but so maybe we could just use X. Which variable is not involved? H.
Okay. Max, what's theta?
55 degrees.
Okay.
Yeah.
Okay. And this 30 feet per second, Kinley, what is that for? Okay. But it didn't say anything about a height.
Zero.
Why? That's what I need. He's kicking it from the ground. And the ground, the height would be 0. So if we are going to set these up, we have x equals 30 cosine of 55 degrees t. And we have y equals negative 16 t squared plus 30 sine of 55 degrees t plus 0. I'm not going to write it, mainly because I ran out of room, but we also don't need plus 0. Okay? Now, before we start solving things, go ahead and take your calculator out and make sure that it is in degree mode.
Not the Are you kidding me? How did that calculator die that quickly? That's ridiculous. Yeah, it is a joke. Wow. I think I'm gonna charge this puppy.
Okay. The first question we need to answer is when did the ball hit the ground? And I would actually write that on your paper. When did the ball hit the ground so that you know what you're finding when you go back to look at your notes. Okay? If I'm asking you for when, that means we're solving for which variable? T. Okay. Now, if I'm asking for when it hit the ground, we need to consider, are we talking about a horizontal distance or a vertical distance? What do you think?
I'm thinking vertical.
Okay. If I throw my marker, okay, that versus like that, it's hitting the ground at different distances, right? But what's always true about the ground?
It's at 0.
Its height is at 0, okay? So when I ask you for it hitting the ground, we're talking about a height, okay? So we're going to take our y equation, and we are going to set our y equation equal to 0. Okay? Now, luckily, we didn't have an initial height, so we actually have two terms with something in common. Yeah. Okay? So we have two answers, either t equals 0, we kind of knew that, or negative 16t plus 30 sine of 55 degrees equals 0. So go ahead and solve for t if we set that equal to 0. Okay, so we would subtract 30 sine of 55 over. We would divide by the negative 16. Tell me what you get. Let's go with 2. What makes this problem nice is that we did not have an initial height right here. And so we were able to factor out a t and solve from there. That will not happen every time. In fact, at least once, if not more times on your homework, there will be a problem where I give you an initial height. At that point, you can't factor. What would you have to do to solve? Well, with that sine of 55, you're probably not going to be able to factor. So what's our fallback when we can't factor a quadratic equation? The quadratic formula, okay? If you have an initial height and you set your quadratic equal to 0, you would need the quadratic formula. But if there's not an initial height, then you can just factor out a t and it's nice and easy. Okay? But I'm just warning you, you will need the quadratic formula in your homework. Okay? All right, let's continue here. Do I need to write the quadratic formula on the board?
I think we got it.
No,
I
we're
think I
good. We were just
remember.
doing the song.
I just don't remember. Like,
What's the
it's just been so
song?
long since.
You don't know the song?
No, that's
What song?
I don't know the song.
I'm sorry, I can't sing
Like Pop Goes the Weasel? X equals negative b plus or minus square root of b squared minus 4ac all over 2a.
Yeah.
It's
horrible. That's the way our childhood songs like this.
Not just this song.
You're not asking me to sing again. All right. How far does the ball travel? Write it down. How far does the ball travel?
All over 2A.
That was really good.
I know.
Write it down. How far will the ball travel? Now, it tells you in the horizontal direction. Okay? So you know that we're using which equation?
The horizontal.
We are using the x equation. Okay? Well, how far means we're actually figuring out what x is, but what are we going to plug in for t? We know that it hits the ground at 1.54 seconds, which means it's going to stop traveling in the air at 1.54 seconds. So we can take that time and we can plug it in to our x equation to get the horizontal distance that it travels. How far? 0.43?
I got
0.45?
Yeah.
I got. I am not.
26.5.
What?
Okay, how many of you are using second answer to plug in? Like you just use the whole entire thing from your calculator. That's why you're getting 26.43. If you're using your rounded answer to plug in, you'll get a little bit of a rounding error, and that's when you're getting the 26.5. Okay? Okay. At what time will the ball reach its maximum height? Write it down so you know what you're finding. If we are talking about maximum height, we probably need which equation? Okay. Did anybody put this graph in their calculator to see what it looks like?
Oh no.
Okay.
Should I do
That
it?
would be smart.
Should I do it?
Thank you.
Okay.
Will you remind me what it is? What is x? $30 what?
The sucker isn't even showing up.
And negative 16 t squared minus plus 30 sine 55 t. Okay, what do we have? A parabola. Okay? What feature of that parabola is going to be where it reaches the maximum height? The vertex. Okay? So let's go old school here. Let's flash back to Algebra 2. When you found the vertex in Algebra 2, you said that the vertex was at negative b over 2a. Since our independent variable is t, I'm going to say t instead of x, but negative b over 2a is where the vertex is. This is going to be your most reliable way of getting the vertex. Now, b is always this coefficient, and a is this coefficient. So please calculate for me negative 30 sine of 55 divided by negative 16. Or you don't have to put the negatives because you know they're canceling out. Right? 2 times 16 is 32. What'd you get, Riley? 0.77 seconds. Observations about that. Okay. In this example, yes, that is halfway through the path. Why? The ball is being kicked at the ground, and then it lands on the ground. So we do have a symmetric graph. When the projectile starts and ends at the same place, yes, the vertex would be halfway through. What you have to be careful of is if somebody hits a ball 3 feet in the air and then it lands on the ground, then your vertex is no longer in the middle, which is why I'm telling you this negative b over 2a. Because in the event that it starts above the ground, you would not be symmetric anymore. Okay? All right. Last thing I want to talk about up here on the board is finding the maximum height of the football. Okay? Well, what did we just find? We just found when it reaches its maximum height. Now I'm asking you for the maximum height, so what should we do? Use this time and plug it in for which? For the y. So the maximum height of this football is 9.44 feet. Okay, so this football went 26 feet in forward, up, 26 feet forward, and 9 feet in the air. So obviously this was not a kickoff situation.
No, it's not even field goal, man. That was a squib kick.
Onside kick? But it went too far.
That'd be too high. And it squib kick. You know what squib kick is?
Yes. I didn't know there was a height restriction on an onside kick.
There's not a height restriction,
But this would not be a good one.
it would not be good.
That's what I was thinking.
You would want hands that, I mean, unless it bounced off the ground. Are we gonna graph stuff like that?
And 26 feet, that wouldn't go far enough.
No.
You have to go 10 yards, right? So maybe this was my 5-year-old son trying to
There
get
you
it.
go.
Yeah, like I said, it could go that high if you like off the ground.
When you get this worksheet, please read through number 1.
They have like it's ingrained in the ground.
Yeah. Better chance of completion.
Exactly.
Yeah.
Mr. Campbell did that for us. Etched them all in.
Yeah, that's cool.
Mr. Campbell?
And then if I check it out, I know. Okay, so a baseball is hit 3 feet above the ground and leaves the bat, whoops, gotta fix that one, leaves the bat with an initial velocity of 100 feet per second, 150 feet per second. The angle that the ball leaves the bat is 20 degrees from the horizontal towards a 20 feet fence 400 feet away from home plate. Will the hit be a home run? So first of all, I want you at your table to take this information and write what you think our set of parametric equations should be, and then stop. You can talk to each other because I'm telling you to do it together.
Yeah. We know what.
Mara, what do you have for your x equation? Good. And our y equation. Nate, what do you have? Nate is not sure what to do for the height. Does anybody have a suggestion for him? Okay. Emily, what made you say +3?
Because it said that he like hit it when it was 3 feet above, so that would be the initial height.
Okay, so he's hitting the ball. He's hitting the ball when it's 3 feet in the air. So that's when it's beginning its projectile. So 3 is our H. Okay. All right, so now we need to prove if this is a home run or not.
On X and Y. Because then that'll
At what time is this?
But we have no times.
Maybe find.
Well, the vertex is going to help us with its maximum height. I don't know if I really care about that because the ball's probably going to be coming down
Yeah,
on its.
let's plug in 400 for X and plug in 20 for Y.
Okay, well, we got to kind of go with one or the other. Okay? We do know that the fence is 400 feet away, right? Okay, So what I'd like you to do, go ahead and figure out for me the time it would take that ball to reach 400 feet. How long does it take? Please make sure that when you're dividing by the entire quantity. So you're taking 400 divided by parentheses, 150 times cosine of 20. Otherwise, it's going to take 400 divided by 150 and then multiply by the cosine, and that's not what you want. Okay? So make sure you are dividing that quantity over. So it takes our ball 2.84 seconds to reach the fence. So now what? Plug that in. Okay, and what is this going to tell us? Okay, so this will tell us how high the ball is when it gets to the fence. Okay? Exactly. Okay, we know how long it takes to get there. Now, how high will that ball be? Okay, so go ahead and plug 2.84 in for t in the y equation. Y is going to give us some sort of height.
Oh, does it go over? That's
You spoiled it.
What do you get?
Oh.
19.
I got 6. He was so close.
He was so close.
I'd be so mad.
Probably hits like that top line, right? That's on the fence. Or Alex Gordon is catching it and it's not a home run anyway. But if Alex Gordon wasn't there to catch it, it would be hitting the very top of the fence. Not a home run. Hi. Oh. You need me? You are a bit early. Okay, here, but you reminded me of that.
You just need to get it.
It's 4.2.
Okay.
That's not bad.
So what you have for me, you have number 2, talks about a soccer ball, and there's about 5 different things you need to do. Number 3 talks about a golfer. Number 4 is a punter, so football, and then number 5 is a cannonball. All right? So we have about 3 minutes left in class. Your job for me is to finish this worksheet. Okay? So maybe you could at least set up all of your equations before you leave.
And I get them like a lot of